Hey, Yao Kai, do you mind if we record this?
Yeah, I want to record this too.
Okay, cool. Wait, this is
I
weird.
think I'm recording at the moment. I'm not entirely sure. Okay, cool.
If it says recording on the left-hand corner, it should record.
Yeah, I see the little blinking red light.
Okay, okay. Maybe it's too early for people. Is that how it is?
Well, it's not too early for me. It's 11, so being a healthy man, I should go to sleep soon.
Oh, that's 珍しいね。
珍しくねえよ。俺もうおじいさんだ。いや、
あ、
もう
その
じいさん
覚
じゃなく、お
悟して、
じさんだ。
おじいさん。
有点太老了。
Okay, I guess we'll wait for another like 2 minutes and then we will start
I think let's
for
just
those
start on the clock
on
and
time.
do the introduction
Okay,
since
cool.
that's gonna take a while. All right. Cominciamo.
All right, cominciamo. Okay, hello everybody who has just joined. This is the panel by Yao Kai Zhang, and we're going to talk about the power of AI. Yao Kai has prepared a slide deck to share, and after the slide deck, we will have a short Q&A session. So I guess I will give the control to you. Maybe you can make a short introduction of who you are so we can get more familiar with you.
Sure. Okay. So here we are. I think it's started. Okay. Okay, so who am I and why you should even bother listening to me? So I had a varied educational background and studied some things that's related to AI, especially in grad school. So I took machine learning, and I also had some exposure later during work at Medallia. Now I'm running my own startup, and we are in the midst of trying to launch our own AI-powered product, not completely inspired by AI, but mostly trying to leverage the power of AI to propel our product a little further forward. So other than being a programmer, I also invest, and because of investing, I'm exposed to many new ideas, and I'm also working on, as I said, working on a startup. And since startups are always a struggle with survival, so I think about that a lot too. Okay, so that's all about me. And next slide. So artificial intelligence and some related stuff. Okay, so a brief history. The name AI is quite loaded. There are many different interpretations of it, but in its current form, most people think about it as what people call as AGI, artificial general intelligence. So basically a thing that's like human-like. But in the past, it was divided into many branches. There was these symbolic logicians that think that they think that symbolic manipulations such as and not if these things are what's going to be AI. And then there's this Bayesian school. So for them, everything's a probability, and you get a prior and then new knowledge. Given the new knowledge, you have a probability of something happening. So Bayes theory is that like A given B, basically that, like how do you calculate the probability of A given a particular event B that happened from it? And then what we're really talking about today is just neural networks. And neural networks is behind everything that we're talking about, like ChatGPT and all that. And it's really old. The idea came in the 1800s, and long before any kind of computer even existed. And its association with artificial intelligence started in the 1920s, still long before any kind of modern computer existed. And in the 1980s, there was 1960s, 1980s, there was the first emergence of neural networks in the exploration of AI, like proper exploration, but that kind of died off at the end of 80s. And it also got a fancy name called deep learning. It sounds a lot cooler than neural networks, deep learning, as if we're into some profound realities of the universe, deep learning. Okay, and then after another 20 years or so, 20, 30 years, in the 2010s, it really caught on. And here's a question for all of you to keep at the back of your head. Why is that? Why 2010s? Why not any time before? Why not any time later? Why exactly then? Okay, so what is a neural network? In the crux, it looks like this. So you got the input layer, which is a bunch of inputs. Let's say that's the data that feeds into the model. And then you got a bunch of hidden layers. The hidden layers are interconnected. The hidden layers might be, in this case, I'm showing a single hidden layer. You could have a lot of them. ChatGPT, well, GPT-4, the model behind ChatGPT, or GPT-3, has 96 layers. And each layer can have many, many different neurons, and then each of them are interconnected. So you have feedback loops from layers after the first layer going back to the first one. So you got feedback loops going on there. The idea of this is trying to mimic what happens in our brain, hence the name neural networks. Every single one of them are called, each circle is an artificial neuron, and these arrows are basically trying to mimic synapses, if you remember from your biology class. Okay, so everything looks a bit hand wavy at the moment, so we'll go through a concrete example. All right, here. I have a model that predicts the strength of a person given its age. All right. But in this case, it says dosage and efficacy, but just don't mind that. Just imagine we're dealing with people's strength. And it's a very simple model. It has a single input and a single output. And it has two hidden neurons arranged in a single layer. So what does that mean? Well, you can't get much simpler than this. Well, I guess you can have a single neuron in the middle, but then it kind of doesn't do that much interesting stuff. Okay, so how does this thing behave? So at first, I'm going to define the dosages or age. In this case, age is normalized between 0 and 1 to make things just easier. So let's say a person is alive between age 0 and age 80. So 0.1 in this case, age 0.1 is just 8 years old. Yeah, so 1/10 will be 8 years old. And then on the right-hand side, on the output, the strength is also normalized. Well, actually not. In this case, I didn't even normalize that. But let's just say the peak of the strength is the peak of that person's. The peak output is peak of that person's thing. And the two curves in the middle these are called activation functions. And that is where the curves come from. So all the curves in this model is going to come from a stretched or squished or flipped version of this curve. So those are the activation. These are the building blocks of your model. And to the left, the input going into the activation function goes through a multiplication and an addition. So if you still remember what the high school math class taught you, this basically is going to change which portion this guy here, the magnitude of this is going to change which portion of this curve you use, and then the sine of it obviously is going to do the mirror image. So in this case, it's doing a mirror image, and it's this is squeezing it because it's a large number, it's squeezing it, and this is just an offset, right? So that picks a portion of this curve, gets an output from here, and then does a multiplication again here. So this multiplication obviously then just flips it. So the output of this is negative now, so it's flipped. And this does similar things, but instead of looking at this, let's look at how the graph actually, the graph looks like this. Okay, so you got the top one, sorry, the colors didn't match. The blue thing is the green thing. I'm sorry. The blue thing is the green thing, and the orange thing is the blue thing. Okay, so let's look at the two curves. You got a curve that basically just shoots up and then flattens out. Another curve basically just goes down and keeps going down, right? So those are the two curves, and you add them up, and then you give it some kind of offset. It's just this thing. This just changes where the curve lies in the y-axis. You end up with this red thing. Okay, so you can see that the red thing crosses 0. When it's 0, it peaks at about 0.1 something, 0.12, and it goes down to 0. Okay, so it kind of intuitively makes a little bit of sense, but it has problems. So here's the result table. The peak happens at around 0.125, but if you multiply 0.125 by 80, you end up with just 10. So this model basically predicts that your strength peaks at 10. And when you're born, you have 0 strength, and when you die, you have 0 strength. Okay, so they're clearly problems. Usually 10-year-olds are not the strongest in their life. And the other thing is, when you die, usually you end up with some kind of cliff. Right before you die, you still can move your body a little bit. So we can't say that your strength is at exactly 0. So we got to modify it a little bit. And the other thing that is very interesting is that we could think about these two curves, one as representing growth, and the other one as representing aging. So that's like life. You are growing and dying at the same time. And your growth happens mostly early on in life. It reaches a peak, and your decline never stops. It's a sad fact, but that's life. So what we need to do is make sure that growth lasts longer into life, and then aging is milder and until it, because it kind of continues even beyond death. So here are actually, this may not be very useful, but I think I got the graph here. Yeah. Okay, so once I changed the model a little bit, it looks now like this. So your peak strength happens at 0.2, which is 16-year-old. And then your strength at death is very low, but not 0. And how would we achieve that? Do I have another thing? Oh, no. I need to share a different screen. Hold on a sec. All right, you might be able to see this. Okay, so this is the first graph that I showed you. And we said there was something wrong with it. So now we just modified some things. You can see that the numbers to the left, these are changing. We modified some things. Now the curve is flatter and shifted to the right. And we also have this cliff at the end. All we're changing here are, I'll go back to my old thing. Hold on a sec. V is the thing. Here.
Hi, Yao Kai. Sorry to interrupt you.
Yeah.
I was just looking at the participants. I was wondering, do you think this has to be conducted in English, or do you not mind conducting it in Chinese as well?
I'd rather do it in English because I probably have to use the recordings for other things. We can do Chinese for Q&A
Okay,
later.
cool. Yes.
Okay. Okay, so here's my slightly better model, and all we're changing in this case is just these parameters. And those are very important because later we'll find that the large language models, the only reason they got better was because the increased number of parameters. And if you think about these parameters in terms of synapses, you got some kind of thresholding going on here, and you got amplification going on here, and amplification or dampening of the signals later down here. So this is trying to mimic how neurons interact with each other. Okay. So that's the better model, and then we need ways to get to here, but that's too technical. But basically, people use something called gradient descent to optimize all these parameters in order for your input to successfully predict the output. Okay, so going on to the a bit more history. Real life applications of artificial intelligence, especially neural networks, really took on popularity in 2010, starting then. Before then, it was mostly a niche thing. So computer vision, facial recognition, audience being Chinese must be very familiar with all these facial recognition devices in China. You end up with these green boxes there that tracks where your face is. It's applied in cameras and all that. You could type in your name or some kind of gesture, action, or even places names in Google Photo Search, and it will locate the photos for you. And there's sentiment analysis applied to text. So when you leave a comment in TripAdvisor saying this is a shitty hotel, shitty will be detected, and then the hotel will know that somebody's angry with them. And collaborative filtering is a fancy name, but basically it's the thing behind Netflix's suggest some movies to me, or the thing behind the box in Amazon that says, I think you might like those. So that's collaborative filtering. These were the first wave applications. So the tech behind these at that point was very well, by today's standards, very small neural networks. They typically are less than 1 million in a number of neurons and quite a bit less than 1 billion in number of parameters. Okay, so to give that to give a context to this, AlexNet, which is I would say the first really successful neural network that had very good application. It had 650,000 neurons, 60 million parameters. Think about those as synapses, and 5 layers. And it was able to do image classification quite well, and doing like edge detection and all that stuff really well. But why then, right? So it's really because hardware has caught on. First in 1999, we had the first smart GPU. So before 1999, before GeForce 256, the only thing graphics cards were able to do was filling pixels. By then, they were able to do transform and lighting. So you can change the shape of 3D things inside the graphics card, not in CPU. Lighting, same thing. So in 2003, the bunch of guys came up with an algorithm that ran on GPU rather than on CPU that had an efficiency boost. And in 2007, we had CUDA was introduced. So NVIDIA introduced CUDA, which is their property supported way of doing general purpose computing inside GPU, and GPUs were a lot more efficient in doing massively parallel tasks. Hence, later, a few years later, we had larger larger models born. And that answers our initial question, why then? Okay, so, but how did this happen? Well, as I mentioned before, graphics card became more and more capable. They were able to deal with more complex logic. They used to be just simple devices that pushes pixels. Now, later they were able to do TNL, and then even later they had tessellation, all that stuff. So all the fancy things. And then the real thing driving that advance was the number of transistors we were able to fit onto microchips. And this is the famous Moore's law. So the Moore's law, going back to the first microchip, 4004, had a few thousand transistors. And well, now AMD EPYC Rome had what? Like, this is a few 50 billion transistors. And with more transistors, you're able to fit more logic on hardware, and that was why it happened. And together with that, we also had decreased marginal cost. I mean, going back to the previous slide, the cost of a CPU didn't really increase that much, but its computing power continued to double in our lifetime. So I mean, you guys were born in the 2000s, so but that was the Pentium 4 era. I was born somewhere here, but 4 is 86, so that's ancient histories by now standard. But the cost of a 486 was approximately the same as the cost of AWS Graviton 2. They weren't that different in cost. So what we got was just a exponential growth in computing power that dollar can buy. So the marginal cost of compute continued to decline. And that triggered the inclusion of general purpose logic into graphics card in the early 2000s, and hence the birth of these more complex models that were able to capture image data, let's say. Okay, then the second wave, basically something GPT, ChatGPT, GPT-3, GPT-4, GPT this, GPT that, AutoGPT, LangChain, blah, 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 blah. So what are they? And why now? In 2017, a paper was published in Google, not in OpenAI, the one that's behind ChatGPT and all that, but really in Google, saying that, well, the previous approach to working with neural networks, the training method was called recurrent neural network. And that thing had a sequential dependency on each of its previous input. So imagine reading, right? It reads like a human read things. It first had to process attention, and then it processes is. The is dependent on attention, and then all is dependent on the previous. So you can't process the next one before you process the previous ones. So attention is all you need. Introduce a new thing called transformers. And transformers basically encode the positional data, the positional information of each symbol, well, token, to be more precise, each token in the training data itself, which means it now can run without dependency on its previous inputs. And that lowered the marginal cost time-wise of training increasingly larger larger models. So with this and the improvements in GPU, we now have models that are 125 trillion parameters. Remember, what we had in 2012, it was 60 million. So that's 1,000 to 2,000 times larger, right? And 125 trillion parameters is about the same number of synapses that we have in our brains. And number of neurons in GPT-4, people don't know because they didn't publish that number. But people are guessing it's probably this in the same order of magnitude as human brain, which is about 80 billion neurons. And the number of layers, again, I don't have a number for GPT-4. In GPT-3 is 96 layers. Remember, we were dealing with 5 layers. And then with the number of layers increasing, you can imagine that the number of synapses will increase in a squared fashion. So because with 2 layers, you have 1 going back. You have 3 layers, you have 2 going back, right? So it's 2 to the power of number of layers. That's why they were able to get this huge number of parameters. And well, aside from being larger, how are they different than the previous ones? Actually, nothing. Basically nothing. They're just larger. And apparently, in this case, the bigger is just better. And we saw everything becoming better. And we even see the emergence of what seems like logic and reasoning after, I think, GPT-3. GPT-3 was 1,000 times or something. Like they had oh, sorry, I'm going crazy. It's not 2,000 times, it's 2 million times. Yeah, GPT-3 is 1,000 times less than GPT-4 in terms of number of parameters. But even at GPT-3, people were observing what looks like logic and reasoning. So basically, you just need to make it bigger. Okay, so what then? If we make it 1,000 times bigger, would it just make things better? From what I observe, the low-hanging fruit days are over. So the revolution brought about by the paper, all you need is attention, has somewhat ran its course. So GPT-4 is already at human brain scale, and GPT-4 had more training than any of us as humans had. We as humans probably consume, a single person may consume, I don't know, let's say very generously, $1 million in education, right? And that's beyond most people. Most people spend between, like, even in the US, 100,000 to between 100,000 and $1 million in education. Training GPT-4 took $100 million, just the training, not the actual engineering of designing how they're gonna put up all these GPUs and connect them together. Just the electricity cost of training it, and then the depreciation of the graphics card is $100 million. Well, if a reasonably smart human were given the training of $100 million, and that he has the capacity of actually consuming the amount of data that GPT-4 had. GPT-4 had something like 45 billion gigabytes of text data fed into it. So that's how it learned all the stuff. The guy would be probably really, well, hugely better at some particular thing than most other people. But GPT-4 isn't that. Look at here. AP Calculus, given $100 million in training, GPT-4 does about 40-something percentile in terms of AP Calculus. And I mean, the the audience here probably don't have that much experience with APL calculus, but that's just high school stuff. But it does really well in things like GRE verbal, and I don't know what this LSAT is. Does really well in GRE quantitative and uniform bar exam, and that's for the law guys, the legal guys, and environmental science, even GPT 3.5 does about 90 percentile. So remember this graph. I'll come back to this later. So what will come in this field later? First is the development of multimodal inputs and outputs. GPT-3, well, anything before GPT-4 really only deals with text data. But our world is made of a lot more than just text. Well, text is just one way that humans codify information, but a lot of information is in the form of images, videos, sound, or even olfactory or central, or you can touch things, right? These are not currently usable in the current AI models. So that's one part. Agents. We already see some developments in this regard, but GPT is a model. What is a model? Model basically, well, I'll talk about later, but the model can't act on the world. A thing needs an actuator. Think of it as a human, right? If all you have is a brain, well, you're quite useless. You can think about things a lot and reason about things, but you can't tell people, you can't make change to the physical world. So that's the limitation. Agents are essentially hands, or the vocal cord for well, actually not vocal cord, because vocal cord is not they already have text output, but yeah, let's just say hands. Agents are hands of the AI models. Recursive invocation, also known as AutoGPT. Most people just call it AutoGPT. Essentially, it will recursively call on itself. It will first break things down. So you ask ChatGPT, okay, how do I, let's say, build a business, right? And it would say you would need to first search Google for how to get a license, and go to register something, and start a business plan, and do market research and whatnot. Those would be individual steps. And normally what happens is you would then extract that particular line and ask ChatGPT, right, how do I get a business license? How do I write a business plan? How do I do market research, right? So instead of doing that, AutoGPT will do it for you. It will recursively call on ChatGPT or other forms of AI models based on its own output. So the output says a list of steps, and it would feed that list of steps back into the model and ask it for further clarification, breakdown. Better infrastructure. So obviously we want cheaper training, cheaper inference, that stuff. And then the latter two isn't really related to the tech itself, but the world will change because of AI. There'll be new business models and there'll be dead old ones. Okay, so here we take a pause on AI and go to what I really want to talk about today. Again, a little introduction. We had farming about 12,000 years ago-ish. And with farming, the marginal cost of food went down significantly. Instead of trying to find another beast to hunt, you now just plant one more seed. So that's the reduction of cost of marginal food. And with that, we had a transformation of civilization. We had, because of abundance of food, and now you have people known as scholars. What are scholars really? These are people that are bored and have nothing to do other than to think. And with that, we had everything following it. Without these bored people, we wouldn't have all the things that we enjoy today. And in 6000 BC, we had domestication of horses. What does that really mean? It's really just a reduction of marginal cost in terms of mechanical work. Feeding a person, well, people are fairly weak. A well-trained athlete can sustain about 150 watts, right? Think of it, if we were motors, we'd do 150 watts without stopping for a few hours. But horses can do 1 horsepower. That's why a horsepower is called a horsepower. A horsepower is like 700. And now you got this mighty beast that will do your bidding. And all you need to do is feed it some grass, which is cheaper than what we eat because we can't digest grass. So with that, that transformed transportation, and we can now mill things because you really don't want to make flour yourself because you are not a horse. You're not very good at it. And then we had wheels, coinage. Think about each of these developments. They all brought huge changes in the structure of our society in terms of what people work on. There, with the domestication of horses, obviously you no longer have, one implication would be that bread would become more of a commodity because horses now do the milling instead of maybe you had slaves before that do these things. Going more modern, telegram, telephone, these changed how fast, well, these lowered the cost of real-time messaging, really. Before then, you need a courier to deliver your information to people from other parts of the world. And obviously the implication that first courier is an actual courier of messages only, courier of information is an actual job. And also because of that discrepancy in amount of information, each localized information, a lot of business models rely on that. Once that is invented, obviously that information barrier goes down, efficiency goes up, bunch of new business would come online, and with that, the old ones that relied on the localized information die. Containers, I'm talking about shipping containers. Well, without that, we wouldn't have globalization because shipping was very expensive, not because the actual fuel that it took to move things around was that expensive. That didn't change. It didn't change even now. Like we have very slow decline in fuel, well, slow declines in actual fuel cost per kilogram of goods that we ship, but once they change the mode of transportation, which has to happen for anything other than the ones that are directly on the coast, you have to move stuff from a ship to like a wagon and then use that to transport it more inland. And huge amount of people were hired for that, the dock workers. But with the invention of containers, that went away, and it is now economical to ship things around. And so that was a huge transformation in the world, actually. Internet, cost of communication, let's just say email, right? Mail used to cost, well, even now, mail costs about 50 cents a piece. Well, you send an email, you don't even think about it. You think it's free. I mean, obviously it's going to cost you electricity, but it's so minuscule, we don't even think about it. Google, that's my favorite example. Before the invention of Google, information retrieval for everyday Joe like me is a huge task. I have to first find a library. I need to know how to navigate the library. And then I need to manually flip through the pages in order to get to the relevant information. And we even have jobs like librarians for that. But with Google now, everything is at a click of a button. I think that we don't think about, how difficult it was to retrieve information anymore. So Google is a huge change. So that basically killed off most librarians. They're a relic of the past now. And public libraries are a lot less important than what they used to be. And with this, it also changed the way advertising works, because but that's the ramification. That didn't really come from the tech. That's just a new business model. Okay, so what did AI bring? What AI really brought, well, this generation of AI really brought the marginal cost of a model down. So what is a model? A model is a simplified representation of the real world. Why don't we just use the real world? Because it's freaking expensive to interact with. I can think about doing something and contemplate. And during that time, I weigh the pros and the cons of my actions before actually taking that action. So that's why we have the saying 三思而后行, because it's cheaper to think than to act. And as a result, we now have simulations of atomic bombs instead of actual detonations, unless you are Kim Jong-il, who don't have good computers. And the most common way we interact with flexible models is human. We give them some fuzzy instruction and they go figure out on their own and come up with some result. Or we codify, the experts in that field would codify what their model, and usually in the form of code, hence codify, right? So that code will be computer code or anything, a protocol, a process in a company, whatnot. So those are all models. An example would be like, let's say Chrome, right? So you enter a web address and magically things just happen. Well, what were those magics? Well, first it has to do a DNS lookup, and the DNS lookup is with an IP, and then you go to the IP, and then you do the TCP handshake and whatnot, all these computer sciencey things. And eventually the data comes back and it knows how to render that because the HTML was written in a certain way, and then that stuff, it gets displayed the way the information, the content generators intended. But that's a very fixed model. In order to get a flexible model, you usually need a person, but a person is always expensive because, well, a simple way of thinking about the cost of a person is the median income of the country at that time. So in the US, it'll be like $40,000 or $50,000 a year, and divided by, and they have to do their relaxation and all that stuff. So 2,000 hours a year, which is only a quarter of an actual year. You pay them 50,000, and each hour comes out to be like $25, right? And also humans are slow, error prone, but humans indeed are flexible. So that's the major difference. But with AI, we now do have a cheap, flexible model. Okay, so why that was a problem? Well, I should have flipped the page, but whatever. The models that we construct before AI they were not very scalable per invocation. Imagine a lawyer. Well, per invocation, let's say per hour, lawyer charges you $350. And that was the price I paid in 2015 or something. And I'm sure it's more expensive now. Why that? Because we are paying for the amortized costs of their education. Okay, and then yes, a lawyer's training took only, I don't know, less than $1 million for sure, which is a fraction of what GPT's training cost is. But a lawyer is very slow at doing things, and it can't parallelize itself to serve multiple customers at the same time. So his model is not scalable. He's flexible, but his model is not very scalable, and hence the amortization happens across his useful working hours, which is only 40 years times 2,000. That's less than $1 million hours, right? So that's not very nice. And the other thing, obviously, you got to pay for his living expenses, because it's a lot more expensive to keep a man alive than to keep a machine alive, because machines are dead to begin with. Same deal with doctors. And the solution for that at the moment we have is to, as I said, codify things using programmers and project managers. Okay, they will figure out, okay, here is the process. These were the decisions they made, and we should fix that and automate that. When the next input comes, we'll get a reasonable output. But the problem with that is, again, it's rigid. You can never have a truly innovative business model when all you're using are existing SaaS software, because these were rigid models. They were built by someone, written in code that don't change itself. And so you end up, well, first you end up with a period of very low efficiency phase. And then you end up just hiring a bunch of programmers to codify what you had in order to increase efficiency. But then you are no longer flexible. Those were the dilemma. You either get flexibility or you get the cheapness. There was no in between. And that was when this whole GPT stuff comes and changes everything, because now you have general purpose models that, well, the invocation was something like, for 1,000 tokens, you pay 2 cents. Okay, so let's say a lawyer's letter would consist of, let's be generous, let's say 10,000 tokens. Incredibly, that would cost you 20 cents. So your flexible model now just costs you 20 cents. Ask a lawyer to do the same thing, well, it's probably a few $100s. Okay, so that is the revolutionizing aspect of this whole change. And the cost of invocation eventually would converge it to the electricity costs. And again, electricity is a lot cheaper than a breathing human in terms of doing anything other than flexible stuff, because, you know, using electrical, let's say mechanical stuff, right? It's always cheaper to have electricity driving a motor to move a car rather than having a person pushing the car. They achieve similar things, but one is just a lot cheaper. And the models that we have, ChatGPT, well, GPT-4 or whatever, one of those models is also BERT and whatnot. They are better than most people at most things. I'm not saying they're better than the experts. I'm saying that most people are shit at doing almost everything, right? I can't do law. I can't stitch. I don't know medicine, but the model knows almost everything, except in most cases, they don't do an extremely good job. And the model also can't do in-depth thinking. Even GPT-4, which has as much brain power as I do given the structure. So here was an example that ChatGPT came up with regarding the same situation that we are in now. I even give it some prompts. So let's look at this. So I said shipping containers lower the marginal cost of transportation. Google lowered the marginal cost of obtaining information. And what marginal cost does a large language model bring down? And it started going some gibberish. And basically the thing is says, oh, it made text processing easier. But that's not the case. Text processing, yes, it was cheaper, but text processing is just a small fraction of our job. Most of the time, text is an embodiment of the models that we have in our minds. So that's not getting the point at all. And then following that, I asked what jobs are in danger of being replaced. Well, it says large language model like GPT have the potential to automate certain tasks related to natural language processing. Again, it's got itself stuck in the idea that natural language processing is a thing that differentiated the large language models versus what had happened before, but that's completely not the case. You can be completely adequate at processing natural language, but if you don't understand the world, all you come up will be gibberish. You can, well, in fact, sometimes GPT do give gibberish. That's called hallucination. But again, it can't give the same talk that as I give. I'm not even an world top expert in this field, but GPT can't do what I do. So that's that will slowly bring us to like what jobs will remain, but that's just an anecdote. Okay, to drill the idea home, every single large shift in society, it really is brought about by the marginal cost of something. A great shift, well, printing, just more examples, printing, 秀才不知门可知天下事, right? Before printing, that's not the case. You needed medium of a cheap medium of information exchange. And before that, people had to hand copy books, and books were prohibitively expensive. Not many people were literate. Printing made literacy a possible goal for every single living human, unless you're, I know, retarded. But before then, it was never thought of as a possibility. Steam engine. Well, coal is again cheaper than horses. So we no longer use horses for transportation. We use fossil fuels. Radio. Well, before radio, the timely information was extremely expensive because the thing traveled, every piece of information traveled at the same speed as physical objects. You need a courier to deliver your message. Well, given a radio, now you can obtain information that was at the speed of light, and also submitting or transmitting electrical signals is quite cheap compared to couriers or even smoke signals, right? 狼烟 is it transmits 1 bit of information, and it costs a bunch of wood. Now we are transmitting, I guess, a few megabits of information every second, and it costs us basically nothing. Before, you need quite a few 狼烟 to do the same thing, to codify what I'm talking to you now. And the same thing with smartphones, cost of on-demand timely information, all that. So all the changes, all the revolutionizing things that you had experienced in the past decade were basically brought up by smartphones. Okay, so how should startups navigate the current, well, not even just the current situation? First of all, most startups are dinghies. They are not ocean-going vessels. You're not that giant Panamax ship, right? Unless you're Sam Altman, who started OpenAI, but he had a track record and people invested a few billion in him. If you had the luck and well, both the luck and charisma, I guess, to get a few $1 billion to start your business, obviously you can become an ocean-going vessel to begin with. But no, most people start as dinghies. So what you can do is not try to propel yourself all the time, but try to ride a wave. Usually when ocean-going vessels pass you by, they leave a wake and ride that wave. So first, identify what changed. By that, I mean, what changed in terms of, drastically in terms of the marginal cost of doing something. And then identify what was once not economically feasible and now is. And then from that, just this is a framework. Then think about what are the ramifications of such things becoming economically feasible. And again, be very cautious about the definition. It has to be economically feasible, not possible, right? It is possible to build a, well, it's a bit like in China when people talking about, oh, if you just spend this much money, we can build seven nanometers nodes, or even 5 nanometers. That's not the point. It's not about whether you can, it's about whether you can build it at a profit. And that goes to the core of any business. You create value by lowering the cost of doing certain things, and you capture part of that difference. And that, think about Google, right? How much did the world become better thanks to the invention of Google? Did it capture it all? It probably captured 1% of it, but that's what a real business should do. If you are burning money in order to prove that you can do something, it's not very, that's usually a fad or some crazy distortion of what should be. Okay, an example would be the shift between 2G, 3G, and 4G. And I'm not saying 5G, and here's a second question, why not 5G? Okay. So how do you make money from these almost tectonic shifts in the world? Usually there are two ways. One is by participating in the infrastructure building. The other one is by utilizing it and finding an application where there wasn't any. Applications usually make more money, but data infrastructures make more steady money, I suppose. So think about containers, right? Once you got containers, the ports became more important. The larger ports became more important than ever. Automation in the ports and all that. Once we had all the .com bubble, the ability to produce and transfer data suddenly increased. Well, now we need a place to host all the computers that do such stuff, which is data centers. So you now can build data center. Data center wasn't a thing in the past. Cryptocurrencies. Before cryptocurrencies, nobody would build ASICs for mining. It was, but once that's there, mining becomes a thing, and therefore you need to produce. It's like building shovels for the gold miners. But always be aware of the probability of oversupply, the dot-com bubble being a good example. People laid down more fiber than they could use in, I don't know, 20 years or something. Google was still benefiting from the fibers that people laid down in, especially YouTube, in the early 2000s. But people reap the benefit, just not you. And application, well, once we had emails, mailing lists became a thing. It wasn't possible doing that before. Online shopping became a thing because internet or smartphones, the proliferation of PC. Uber became possible because the real-time location of someone is now accessible because of phones. And TikTok became possible because of 4G, because before 4G, the unit cost of transferring a bit was too high. So these short videos really wasn't economically feasible. 4G made that possible. And going to AI, obviously in terms of infrastructure, agents, those are the hands of AI models, agents. So connect them to existing stuff, make them capable of modifying the world is going to be a tedious work, and it will go on for many years, but somebody has to do it. And when somebody has to do it, somebody will make money. The ability to fine-tune large models, obviously, GPT is a ginormous model. It has a few 100 trillion parameters. And when you want that to adapt to a particular, so how do you specialize someone, right? Let's imagine GPT is a well-read high school student. How do you specialize this person for, I don't know, physics, astronomy or something? Data storage, AI needs completely different data storage than other things. Usually they use vector store, so that became a hot thing. Miniaturization in terms of the model and the devices. At the moment, AI is limited to running on the cloud because you need racks and racks of graphics card in order to execute the model, which is called inference. But we don't really want that. We want that running on our phones, right? So that might be an opportunity. And again, cheaper training and inference and all that. Application, obviously, the things that I think are really going to be in trouble are lawyers and doctors. Lawyers and doctors, if you think about them, they're just big bags of information, right? They don't necessarily need to be smarter than anyone. They just need to know more. And that's where the AI excels at compared to humans. And so any job that involves big bags of information is going to be replaced. And these big bags of information are usually very expensive. Because first, you need good memory, and good memory is hard to find in a human, very easy to find in a computer. They're very cheap. And they need a lot of training. But the speed of ingestion of information between a human and a computer is just not comparable. So you are screwed. There'll be a lot of opportunity of replacing these high-paying jobs that are basically big bags of information. PR, well, because they mostly write useless articles. Oh, oops, I clicked something. Sorry. Yeah, so that probably will be the next field to be done away with. And the next thing is the thing I'm interested in, one-time software, one-time use software. As I said previously, all the software were codified by professionals to be used in that particular instance. And that limits the, so imagine if there's a cutoff point, the cost of development would be the cutoff point. So any use case that are lower than this has to be covered by flexible models, either in terms of like experts or maybe sometimes through AI as well, but then you need to be reasonably well versed in the field in order to use it. So I think in the end, we'll end up with a lot of software that just on the fly created and use it once and then discard it. Okay, so what won't be replaced by AI? I think that goes back to human nature. Things that make us think that we are special. For example, even though you might be able to get a DoorDash guy to deliver your food, it just feels special to have your own butler to get your food, right? It makes you feel better. And things related to showing off, things that you can't objectively value. Well, let's say modern art. To me, they are worth absolutely shit. But for other people, they're worth a lot. So how do you develop a model that captures that? And even if you do, they're not buying for the painting itself. The painting, as I said, may just be a piece of crap, but it's the person behind it. So that will stay. Things that are limited by physical laws. Even if an AI model can, well, let's say Boston Dynamics, right? You can build something that looks like a human, and it may even be able to do backflips. But after 20 years, you would think backflipping robots are the common case. And you'll be surprised to hear that, holy shit, your robot can't do a backflip? You call that a robot, right? But looking at a human, you still get impressed by people doing a backflip. So that's because we share the same limitations. Our body had limitations. Within the limitations, if you were able to perform better, then people value that more. Like athletes, they will all stay. These jobs will all be there. Things that are limited to speed of light, obviously, unless we have a new breakthrough in physics that find that we can actually break the speed of light, then we by that, what does that mean, right? So if, let's say if some of us in Mars and some of us here on the Earth, information travel is going to take quite a few minutes. Those are the things that are limited by speed of light, and you can't really change that. And anything that would benefit decision making in the absence of information due to this speed of light thing is going to be valuable in that circumstance. Cost of energy, well, cost of energy steadily goes down as we discover more energy sources, but it's never a cliff. So mechanical work that move one thing to the other place, well, that's going to stay regardless of whether we have AI models or not. And the other thing is perishable stuff. Well, it's a bit cliche, but we humans are valuable because we die. Otherwise, we're just a bunch of us, and be a bunch of us that don't die, and we have infinite time to grow, and everything becomes just mundane. Because then it's just a competition of who stays alive longer. But since if you don't die ever, everybody stays approximately the same as alive as eternity. And everybody knows everything. Okay, towards the conclusion, and that I said, what I really wanted to talk about wasn't about AI, it's really about a framework of thinking. So first of all, we all want infinite things. And we want the infinite things to be infinitely flexible, right? Going back through history, that's basically what happens. You got you don't have cars, then you first have a Ford Model T, that becomes approximation of infinite cars. And then we now have cars that are configurable and whatnot. We want, special cars, handmade, and all that stuff. And what really that means is we just want a thing that does what we want. And usually we want infinite stuff and the way we want it. And the way we want it is usually slightly different from the next person. And in light of that, all the major changes in society is driven by a change of marginal cost of something. And when that happens, there's disruption. There'll be people losing jobs. There'll be people making new jobs. There is even cases when you got societal or political changes. For example, radio. If you think about how election happened before the invention of radio. And during such disruptions is when new money emerges, and then these new money usually comes in the forms of infrastructure development or new applications. And that's just my own framework. Take it with your own grain of salt. And after this, I want to rant about things that I really hate. Okay, so on the left are the things that I think are revolutions. On the right are the things that I think are fads. Okay, so large language model, so all the GPT stuff, I think that is going to revolutionize the world, and because it lowers the marginal cost of a flexible model. SpaceX, because it lowers the marginal cost of shipping something to space from, I think it was reduced by like 10 to 100x or something. Cryptocurrency, well, in places with no trustworthy central government, that's the only way you can get money in and out of something. That's the, and hence it lowered the cost of storing value and transferring value, two of the things that a currency should do. And 3D printing, manufacturing used to be subtractive. 3D printing is additive, not addictive, additive. And so we can now make a lot more things, different shapes, more flexible shapes than we could before. And also building to order becomes a lot cheaper than what we had before. Autonomous cars, obviously, driver is the most expensive part of a taxi. Everybody knows that. So getting rid of a person lowers the, again, converges your cost to cost of motion, which is energy, plus the cost of decision, which is electricity. Solid state battery, the cost of manufacturing battery is probably going to get reduced a lot with solid state battery, and the cost of packaging them get a lot cheaper too. Augmented reality, well, you can see that through the pilots, right? That once augmented reality really kicks in, I think that would happen probably in the next decade or so, when the cost of hardware plus software really lowers. Everybody becomes their own pilot. If you're an F-16 pilot, you see a lot more than I do. And such information is valuable. It's just I can't get access to them now. Okay, fads, pet rock. For ones in you that haven't heard of pet rock, it's literally a rock sold as a pet. So why it's a fad? It did not reduce the cost of anything, because it's just a freaking rock. And 5G, why is 5G useless? Well, think about what 2G promised us. 2G promised us always reachable and asynchronous communication. You could send messages, which you couldn't before. That's 2G. And you can reasonably get a bit of data transfer. So text transfer was okay. Image, maybe. Video, not so much. 3G, well, with 3G now, you got multimedia on your phone. GPS became, well, basically omnipresent. So everybody knows where everything else is. 4G, now your transfer speed can deliver on the promise of like seamless video conference. We are relying on that now. What is the promise of 5G? It says it's going to be much faster. Okay, so what for? This is already good enough. And it says, oh, we're going to reduce the latency. I'm like, but that's limited by the speed of light. And usually when you're talking about like remote operations, like that, first of all, how the hell do you even get a robot to there? The cost is at getting the robot there, not the signal. Secondly, you still need a cable for 5G to work, the cell station. So how does that even help anyone? Plus, 5G has a bunch of other issues. So if you guys are interested, you can read up on it. It has like 3 standards that's just smashed into one. Fintech. Why I think fintech is a fad, but cryptocurrency isn't. What problem is fintech really trying to solve? What costs went down? Nothing really. It says it should solve the problem of trust. Okay, but most people, like cryptocurrency basically already got rid of the trust issue in exchanging value. But fintech is just trying to build the existing financial stuff on top of crypto. Not necessarily cryptocurrency, but the whole distributed transaction thing. But are we really worried that the banks will forge its own ledger to defraud us? Right? I don't see what problem it's solving. NFTs. Well, yeah, again, enlighten me. What cost it didn't not lower the cost of ownership, because the cost of ownership of images is basically zero. The cost of owning a painting, like a physical painting, is almost zero too. So what is this then? People say, oh, now you can claim I own this thing, you don't, cheaper. Yeah, but the cost of proving it isn't that high. The cost of enforcing it is high. And enforcing such a contract is a physical world issue. You need someone with gun, i.e. the police, going to their place saying, okay, you are arrested for breaching a contract or something. A human has to get involved. Until we have robotic enforcement of law, it's not very useful. Web3. How many of you are actually worried about privacy? YouTube has my comments and my videos. Oh, big deal. So if the problem didn't exist to begin with, what cost are you reducing? Metaverse. Like, if I want to see someone, I go to their place, I see someone. Metaverse did not really, it can't replace the face-to-face intimate experience, and the cost of it is basically, and it's more expensive than video conferencing. So what is it trying to solve? So those are the things I really hate. I think these are just fads, and I think everyone that invests in those crash and burn. Okay, Q&A. Those were the questions that were collected beforehand, and we'll have some time to do the actual Q&A live here later. Trust in a startup and how to find a technical co-founder. The best way to find a technical co-founder is to hang around a bunch of potential technical co-founders and work with them. Don't play with them, but work with them. And I think that's not just for technical co-founder, for any co-founder, work with them before you decide to team up and do a startup. And that's because knowing someone as a playmate is not very useful when it comes to workplace decision making or problem solving. AGI, well, yeah, I think I just talked about AGI, so that doesn't matter. In the terms of future education, do you think opportunity will be the? I don't know myself, but following the framework, you should be able to identify the obvious culprits, i.e. the big bags of information, and the ones that are expensive to train. So, but the things you can't really replace are the human touch. So if a teacher is just a machine-like information deliverer, then he or she might be replaced fairly soon. What do you think about distribution of technology, intelligence? Blah, blah, blah. What is this? And the intelligence, like in the future. Blah, blah, blah. So, following on my previous assertion. Most people do most things really bad. They are good at one or two things. So the ones, it might become a societal problem because there will be massive numbers of people that underperform AI in everything. So finding a way for them to sustain themselves will become a societal issue, because humans are mostly incompetent. You have a few competent people and most of them are incompetent, and they will end up as either human agents for AIs, or they will live off, I don't know, universal basic income or something. But living off universal basic income is going to be a really bad experience, because we as humans don't thrive on just getting handouts. Like, part of us wither and die. Word is immersive affecting own no code car startup. Okay, so I kind of touched on this before. So we're building this AI powered part of the product. The most difficult part of adopting our software is understanding the business, their own business model, their own need, and translating that into configuration. Not necessarily code, but configuration. Getting rid of code just means that we have an easier way of specifying what we want, but not knowing what they are specifying is still going to be a problem. That basically means most people are really bad product managers. And AI is going to greatly affect that. And I'm not really feeling threatened by AI in this case, because I was looking at the jobs, because remember the graph that I showed before, the jobs that AI are really good at and really bad at. They're actually really bad at coding. Even small problems, the problems are fairly limited in scope. They can't solve well, not to mention the difficult ones. They can't even do the easy lead code questions 100%. And so programmers will have, I think programmers are still safe most part, unless you are like the really bad ones. The bad programmers will definitely get replaced. Again, the bad anything person will get replaced. And the space above which humans can occupy would mostly depend on this graph. So let me just change the share here. Okay. Bar exam, that's a legal thing. That's why I think lawyers get replaced, because GPT-4 can get 90th percentile. Right, so that they're better than 90% of humans. And going from 10th percentile to 90th percentile. And then if you look at others, evidence-based, well, SAT, they're like 93 percentile. So, well, those are fairly standard things we'd expect. Not everybody can do SAT, but SAT is not that hard. And GRE writing, they're really bad. They're never that good at it. So that probably means, given the 1000x increase in model size, there's no improvement here. So writing something really meaningful is still a human thing. And if you look at something later, art history is a done deal. But we already know that art historians don't make that much money, so that doesn't really change much. Biology is a done deal. Again, the AP biology, so high school biology, is basically rote memorization, falling into the same category as AP, as art history, basically bag of information. Chemistry, there's some deduction going around, but they still do pretty well. And if you do literature, they're bad. So here we go. We got one thing that they are consistently bad, despite an increase of 1,000 in size. They're as bad as their predecessor. I mean, GPT-4. So go through this list and you will find out what things AI is not going to improve on. Here's coding. With a massive brain, it can't even solve all the easy questions. So, but most humans can't either, but like the ones in Google, hired by Google or Facebook, the ones that you stereotypically you think as good coders, they probably do 100% of these. So that's why I think good coders still can't get too threatened yet. And yeah, go to this thing and check that out. Going back to here, for people who are about to graduate, do you have a suggestion in light of this? Well, if you are mediocre in your own profession, you are probably screwed because of AI, because then your value as a flexible model is no longer. And but if you're in the fields that need a human touch, obviously you won't get replaced. And if you are better than the flexible models that AI can provide, obviously you have value. Because a lot of times people pay 10x more for 1% improvement. And it sometimes, well, a lot of times it makes business sense too. All right, so those are the Q&As, and I shall switch to Chinese for the rest of these. Metaverse is such a stupid fad. Do you think it is essential for a design student to learn computer science if we want to start with this application? No. 这个其实不需要 computer science， 你只需要学一点数学和统计就可以。其实 AI 大部分东西都是统计学跟数学，然后也不是特别的难。如果你就是即便你没有，即便你不太会做什么微分方程，里面有很多是微分方程的东西，但是即便你不会做，你知道它的原理就可以。对，就像你哪怕不会做乘法，你会用计算器就可以。你知道乘法在干什么，然后你会用计算器就基本足够了。但是更需要的是 startup 这里更需要的是 business sense，因为 你大概率不会是那个推动 AI 技术向前发展的人，你只是个应用者，你要找到的是适合应用的地方。绝大多数的人，像包括我也一样，我们要找到的都是怎么样去更好的就把 AI 应用到一个我们熟悉的领域里面，发挥它的作用。为什么 Web3是个 scam？因为 Web3说了半天都是说什么啊，你拥有你自己的数据，然后没有人可以篡改你这个数据，然后什么之类的东西。但是我在 YouTube 上留言，我在 Facebook 上留言，我也不担心这个事儿啊。然后我写下来的东西大部分都是垃圾，我也根本就不想要它呀。然后存下来是要钱的。Web3的前提是那个 Web3前提是 distributed ledger 嘛。所谓的 distributed ledger 是每个人都存一份数据。曾经你的数据只存在 Facebook 的数据库里，现在你的数据存在每一个人的电脑上，你不觉得这很神经病吗？而且我存的都是垃圾，因为我产生的大部分信息都是垃圾，每个人产生的大部分信息都是垃圾。不是老师啊，我只是个码农。这个 AI 在工业4.0，首先我不知道工业4.0是什么，国内的这种工业4.0啊，什么乱七八糟的名字特别多，每个人在造概念。然后数字孪生也是，就是数字孪生这个东西呢，又是个概念，而且都是很 fuzzy 的概念。你说让我们可以更好的观察整个生产系统的活动，当然是有用的。然后 multimodal 的，就是我刚才提到那个 multimodal 的那种 AI model 的话，它很有可能可以帮你生成对应的，就是就你就工厂里面对应的 sensor 地图之类的，这个很有可能是可以的。但是现在没 multimodal 的应该还没出来，出来之后很有可能这就是一种应用的场景。What is a counter solution? Refuse the using quote. 那这个我觉得没有任何 solution，世界就是变得更不平等了。你任何的技术基本上都是这个样子。你曾经钢琴家，我弹的很烂，但是我弹的比小镇上的人都好，我就可以在小镇上什么赚点钱，我给什么小镇上的富人赚点钱。现在李斯特的 CD 只要 CD 都不用买了 ，Apple 上去下载一个3毛几一个，对吧？我可能更便宜，弹的比我好多了，谁要请你？弹的还那个声音还变的，这东西任何的规模化的东西都是会让这个 inequality 变得更严重的。inequality 的来源就是人的无能嘛，大部分人都是无能的。那每一次这种升级都会让这个无能的底线越来越往上抬。那你只有超过那个底线，有人才会额外付钱。那所以这种东西就一定会是越来越淘汰，就是越来越多的人变成不产生正面价值的。The next one in English. Oh, you mean the counter solution? This one?
Yes.
Oh, sorry, I didn't realize it was that. I didn't read the name, so I was talking about it's an inevitability that the society becomes more unequal when technology progresses, because most people are incompetent, and as technology progresses, the threshold of incompetence that's no longer generating positive value increases. Well, competence, not threshold of income, threshold of competence. So more and more people will be excluded from actively constructing a better world. I don't see a way out of this. So that's why I was talking about potentially people will live off UBI, but then they will feel worthless, and that's not healthy. So I don't know what the solution is. Again, I'm just a programmer, and I don't really want to. I haven't spent much time thinking about societal issues. AI 和科技行业 in the acknowledgement section, I've mentioned there was there's a YouTube channel called Stats Quest. In fact, one of my graphs was taken from them. So that gives you a very good foundation for what really AI is. But in terms of newer applications, I think if you really want to do a startup, your best source of information is yourself, like your localized knowledge, and like think about all the stuff that you're doing that are marginally expensive. So for every additional step you take or every additional event you handle, you pay a lot, but you don't really want to pay. And yeah, that might be, and that usually currently is, I know, handled by a human, right? So that these are the acknowledgements, and most of my information is from, well, all the years and when things were invented were from Wikipedia and StatsQuest for the tutorial. And the last one is the stuff I'm working on. Have you worked on and Siena's work on any product that integrated into hardware? Here is a very interesting thing. We've all seen that, which is the self-driving stuff, especially the L5 thing, right? Like the fully autonomous driving. And I think what they used to do was completely wrong. So the problem we have now is the lack of ability to generalize when an unseen input is received. So we as humans, when we're driving on the ground or on the road, we see some stuff on the ground that's unrecognizable. It may be a completely new thing we've never seen before. We would really quickly try to categorize that thing into like dangerous / not dangerous. How do we do that? We don't even think about it that much. Usually we just know. How do we know? Because we have a model in our world, in our head. We're trying to fit that stuff in the model in our head. And again, the ability for humans to drive didn't really come from our acute senses. We are really, our eyes are not as good as eagles, right? Our hands are not as strong as, I don't know, giant cats. And our attention keeping is not as good as some other animal. But why are we able to drive? The main difference between us and the things that can't drive is the brain. And what is the brain? The brain is a flexible model. So with all the energy that all the autonomous driving guys were spending on vision, I think that's the wrong road. Because vision isn't that important for a human. You can remove my eyes, I'm still me. I'll be a very sad me, but I'm still me. So spending all that energy on improving sensors on a car, it's not right. The lack of ability for the car to autonomously drive is not coming from the lack of sensors. It's coming from the lack of knowledge, i.e. lack of a flexible model. So that's why it can't generalize. So I think with the advancement in large language models, we'll greatly shorten the moment when we all enjoy level 5 self-driving cars. In terms of other hardware, I don't know. I don't pay much attention to the hardware because hardware usually there isn't much you can do about them because you're moving atoms, not bits. So they move much slower than software. And moving atoms, until the moment we can get machines to build machines autonomously, that's not very interesting. Any other questions? I think we are done with all the questions.
I think so too. If anybody have any other questions, just feel free to drop it in the meeting chat. And also, this PowerPoint, this slide deck would be shared to everybody who has left their emails with the form. If you haven't, please leave your email in the meeting chat so I can send it to you, or Yao Kai can send it to you.
Yeah, I think that's
I
it.
guess.
Thank you all.
Thank you, Kai, Yao Kai.
哈哈
Oh, okay.
等一等，其实我还有个问题
啊，
就是想问一下，就是你怎么看呢？比如说，就是这种 AI 的道德伦的问题，比如说它对这种它产生内容的这种，当然这肯定是个老生常谈的问题了。但我想看一下，从你的角度看，就这些，就是 AI 在这种道德伦理上有没有一些比较模糊边缘、这种灰色地带，需要就是谨慎一下的地方？
我没有想过这方面的问题，因为它不能赚钱。
但是它可能会损害到或者某些人的利益吧，就是
对啊，
它
当然会损害到，但这个事情我也没有能力去控制。
OK，
就是一个我既不能控制，也不能，我既不能控制，也不能利用它去赚钱的事情。除非哪天这个变成一个 political agenda，然后开始有 vote 了，那我可能会产生自己的影响，不然其实我也啥都不能干。
好的。
All right, good night. Sorry, good eve the morning. Morning. 拜拜。
Okay, bye bye. Thank you.
拜拜，感谢。
Bye, everybody.